Hey everybody, today I am going to continue talking about the node-based JavaScript tests for the Zulip project. So my audience today consists of people that are trying to build new features in Zulip's client software written in JavaScript who need to write node tests. Um, and I earlier went through the first three example tests within the Zulip project under the web test directory. And today I'm going to continue on with example four, and I'll try to get through the last four examples, but I usually try to stop when I feel like I've kind of given a good chunk of information to digest. So one nice thing about all of these examples is that they're relatively short. Some of the later examples get a little bit longer. This one's 150 lines in contrast to the earlier ones. But all these examples are pretty heavily commented. So like if you had watched, even if you hadn't watched my earlier video and you just read these examples on your own, you can see here that this first large block comment in example four kind of reviews what we have done so far. And as it says, we've kind of used fairly straightforward testing techniques on some really core modules in the Zulip system. And I want to reinforce something that I said earlier, that like reading these example tests will not only introduce you to techniques for testing, obviously, but they will also kind of give you an introduction to some of the major objects in the Zulip system. And if you've already kind of poked around in the actual Zulip code, it'll reinforce those concepts for you. And if I scroll down a little bit, we've introduced the notion of zrequire, mock ESM, assert equal. This is like the boilerplate at the top of every function where you require assert so that you're able to use the assert module from Node itself. And then you require lib namespace so that you're able to use zrequire. And we'll get to mock ESM in a second. And then you require lib test in order to get the run test helper. So let's just see what I said here. An app is pretty useless without an actual data source. Okay, so it starts talking about the event system in Zulip. And by the way, I really encourage you to read these tests. I think it's helpful for me to kind of give you a high-level picture, but I'm not going to explain every line in great detail. I'm just going to kind of give you the big picture. But you can see here that we're starting to use this concept of mocking, so that we're going to use mock versions of some of our libraries, the activity library, the message live update library, and so on. But then we're going to use real versions of other modules. So the people module in Zulip, as I covered in the earlier video, is basically where we do things related to users. And then we have this server events dispatch. And the server events dispatch module in JavaScript is extremely important. It's like the essence of a chat app, that a chat app is dynamic. So you're always getting these messages coming from the server. So like, I probably shouldn't use the word message, like little event payloads from the server. The only reason I don't want to use the word message is because like a message means something very specific in a chat system. But you get these events that could be about a new user just joined the system, or let's see, maybe a setting changed. Maybe you were on another client and you changed some setting, and then the server has to notify your other clients about this new setting. Yeah, there are probably so many other examples. I'm kind of like a little rusty on that. But so we create this user Bob, and then we start having these, run tests. And the structure of almost any test is that you initialize some data, maybe create like a few constants. You make an assertion, and this assertion here is kind of like, it's not quite a sanity check, but you want to say the structure of this test is that first we say Bob's not a known user, and at the end we say Bob is a known user. And the way that we do that is we dispatch an event of type realm user that is adding Bob. So if the call to dispatch normal event is working correctly, then that should have the side effect of adding Bob to our system, and the client code that provides the interface to find out if Bob's user ID is in fact a known user ID resides in the people module. And I'll review again that we use the z-require to import the people object. So we're using the actual people code here. We're not doing any mocking when it comes to calling methods on people. But here's the key thing that this example starts to illustrate, is that when you dispatch an event, for a realm user add, one of the side effects of that event is it's going to redraw the bots list. And that's like not only kind of an expensive operation, but it's really difficult to simulate in Node and even verify. So all we do here is it says we need to override a stub here before dispatching the event. So we call this override helper, which by the way is passed in. When you call run test, you give it a string, which is just a label for the test, and then you give it an anonymous function that will be executed, and that anonymous function will receive as at least one of its parameters this override helper, and this override helper is a function that allows you to override settings users with redraw bots list. And so I'm going to go back up and show where settings user is originally created. And you can see here that it is created using the mock ESM helper, and that mock ESM helper was brought into the system via requiring lib namespace. So, the reason this is the fourth example and not the first example is that you generally want to avoid mocking if you can, particularly when you're, if you think about objects as kind of being a tree, you have objects like kind of higher up the tree. I'm using tree like an upside down tree like you normally think of in computer science. Higher up the tree, you have branches that have all of these dependencies kind of, below them. Those objects can be really difficult to test without some level of stubbing. But when you get down to the leaves and when you get to objects that are more self-contained, you should be able to test those objects directly. And the Zulip project encourages you to test things as directly as possible. But there are certainly occasions where that would be impractical, and that's where this notion of stubbing or mocking comes into play. And I say here, it's actually a little surprising that adding user does not have side effects beyond the people object in the bots list. But anyway, so then I get on to another test that essentially processes an event, and you'll see that this test is very structurally similar to the prior test. We initialize some data, we add an active user to our people system, we create a new Bob, we create an event, we do some stubbing to remove side effects, we dispatch the event, and then we call a people function to get the user, and then we assert something about the user. Now, one thing that I apparently omitted from this test that I think could be fixed with like a one-line, PR, is that I didn't make any assertions about Bob before I dispatched the event, unless I'm misreading this code. Yeah, I think if I had been more thorough, I would have done what I did in the earlier test. When I added Bob, I first asserted that he was not a known user, and then at the end I asserted that he was a known user. This test, I believe, is still valid. I believe it's actually testing something. So we're asserting that the user's full name is the artist formerly known as Bob. I mean, yeah, I really should have asserted that before we did this, if you go up to the top here, his original full name, was Bob Roberts. What I should have done in this test is made an assertion earlier, like probably about right here before I started actually doing actions, that Bob's full name at this point is Bob Roberts. But hopefully from example 4, you understand the structure of a test that is testing something that has some side effects that you don't care about, but that does have a very important thing to do. Like when you update a user, like it's extremely important that the full name of the user gets updated, and that when you pull a user out from people using the get by user ID function, that indeed the that user has been correctly updated according to this event that is processed by server events dispatch normal event. Let's move on to example 5. I think I kind of covered that pretty well. Of course, you should go back and read it kind of more line by line. So what am I saying here? I'm saying our test from an earlier example verifies that the update events lead to a name change, but it kind of glosses over other interactions. And so I said we can go a little further and verify the sequence of operations that happen during an event. And in here, we actually, I claimed that we're going to build a lightweight stubbing system. So let's see how this works. Notice that we're starting to test code that has all kinds of fan out from like a higher level object. So we have to mock like all of these other systems that are going to have side effects that we don't care about for the purpose of our specific test. Like it's very difficult for a test to capture like every behavior of a system once you start kind of, working your way up the tree. Okay, but at any rate, so I have this, I simulate this message lists structure, and I think the pluralization there is intentional, where I say that that a filter on messages can apply locally, and I think that'll make more sense when we get further down. And then I do use zRequire to bring in actual code that will be exercised, that will be exercised in contrast to mocked code, which is stubbed out. I created user Isaac. I think I said in my earlier video that there are different themes for users in the Zulip test framework, and one of them is like scientists and mathematicians. But here we start to create a test helper, and the test helper, let's see, it returns redirect override. We override a module with the function name, and we push. Okay, this will become a little more clear once we see the test. So we're going to run a test where we insert a message, and again, the template for almost every test is like the first line or couple lines just clears out data, so we're clearing out the message store. Then we're overriding something that where we don't intend to examine any of the side effects. We create this test helper that we just saw a little bit earlier. Then we make a new message, and this is not a complete message like you would see in the actual application, but it has all the representative fields that are relevant to the test here. So we create a new message for Isaac, where the sender is Isaac. The message ID is 1001. We have some example content, and it's under the topic of foo. And okay, remember when in example 4 in the last test where I was kind of chiding myself for not having the original sanity check assertion? I was a better programmer here, and I first assert that this, when you go to the message store and try to get the message with ID 1001, that it's not there yet because we haven't done anything to introduce it into the actual system. All we've done is declare it in the test. But anyway, what I do here now is I redirect all of these mocks, or all of these functions under these mock objects. I redirect them, which basically means that I override the module and the function name in a way that when that function is quote unquote called, I mean, it's not quote unquote called, it is called, but I should say the quote unquote function, which is not the actual application function. When that function is called, we push just the name of the module and the function name onto the events array. And then now we actually start doing things. We reset the current filter using narrow state. We insert the new messages, and we call insert new messages plural with just this single message, which I already talked about pretty thoroughly. And then we make an assertion about all of that all of these events happen as a side effect of inserting new messages. So backing up, I kind of got a little probably too into the weeds and didn't give you the big picture here. The insert message function is intended to verify that whenever you insert a new message into Zulip, you do want to have all of these side effects, and we can't examine the ramifications of every single side effect, but we do want to understand. Remember that tests aren't just for preventing bugs, they're also for documenting the behavior of a system, and also stabilizing the behavior of a system. We want to assert that the helper, that the events that happen as a result of calling insert new messages, that the huddle data module will process the loaded messages, that the message util module will call add new messages data, and it'll call add new messages twice apparently. And then the unread UI module needs to update unread counts. And the UI there stands for what you think it does. It's user interface. So every time a new message comes in on an actual user interface level, we need to update unread counts, like in the left sidebar and other places. I'll skip a couple, but the stream list, we need to update the streams sidebar. And that's what this test tests. I think I'm going to end there. I feel like that's a good stopping point. So in my earlier video, which I'll link, I covered the first 3 example tests, and then you see that example 4 and example 5 get a little deeper, and they both deal with this notion of mocking. And again, the key thing for mocking in Zulip is that you have this mock ESM helper that allows you to replace code with essentially as it says here, with an empty JavaScript object. And that's a very powerful testing technique when you're testing code that is higher up on the programming tree, code that has more dependencies. So I'll leave you with that. I hope this has been helpful, and I will try to get to example 6 and example 7 sometime in the next few days. Thank you.